Continuing on our adventure to try to solve equations for x or whatever our variable happens to be, we'll sometimes come across linear equations like this. Notice that we still have just a single variable. X is our only variable, but it shows up more than once. It's really hard to get something by itself if there's more than one of them. So our first job in these types of situations are that we need to get the x's together so that we can combine them, because they are like terms, so we should be able to put them together. The problem in problem 13 here is the fact that 3x is on one side of the equation and 7x is on the other side of the equation. We can't put them together when they're on different sides of the equation. They have to cross over that wall. The way that they can cross over the wall is to add or subtract the whole term. So we're either going to need a minus 3x from both sides, or we're going to need a minus 7x from both sides. It totally does not matter which one you do. Just pick one. I'm going to subtract 3x because it's going to make my value be positive over there. That's just a personal preference, but like I said, it really doesn't matter. In this case, I'm going to minus 3x on the left side of the equation so that it will move and go away. And then I'm going to minus 3x on the other side of the equation because I have to keep it balanced. So let's see what happens. Here the 3x minus 3x goes away, and I'm left with a negative 5 on this side of the equation. On the other side of the equation, I now have like terms that I can put together. I have 7x minus 3x, which is 4x. And then there was a plus 12 there from before as well. That's not a like term, so it needs to come along for the ride. Now at this point, notice I have a new equation. I do have an x, but the nice thing, I only have one x. That's great. So what that means is I can now work to get this x by itself using the methods that I did and talked about in the last video. So to get the x by itself, first thing that we want to do is, right now it's being multiplied by 4 and added 12. Remember, the farther away it is, so separated by that plus sign, that's the weakest link and the first thing that needs to get undone. To get rid of a plus 12, I'm going to minus 12 from each side of this equation. Plus 12 minus 12 is gone. On this side, negative 5 minus 12 is negative 17 equals 4x. All right. Now, down to a single x. It's almost by itself, but there's still a 4 here. The 4 is being multiplied, so to get rid of a multiplied by 4, I'm going to do the opposite operation, which is divide by 4. Here, the 4's cancel out, leaving my x alone, just like what I want. And on the other side, I have negative 17 fourths. That cannot be reduced, so it's okay to leave it as an improper fraction. We'll just leave that as our solution there. All right, now, let's take a peek here at number 14. In number 14, again, I have more than one x, so my first job has to be to get those x's together. So there's an x here and an x here. Now, very, very important is to recognize the difference between what we do in problem 13 and what we do in problem 14. In problem 14, notice that I have a 5x here and a minus 3x here, but they're on the same side of the equation. If they're on the same side of the equation, you just put them together exactly the way that it says to. 5x minus 3x is 2x, and I can rewrite the equation just like that. So on this side, I couldn't put the 3x and the 7x together because they were on different sides of the equation. So I had to do an opposite thing to move it across. I had to turn traitor and go over to the other side of the equation. In this side, they're already on the same side. They're already friends. You just do exactly what it says. Then, I'm not quite done, but I do at least have it down to a single x. There's still being a 2 multiplied out in front, so I'm going to divide by 2 on both sides to undo that. 2 divided by 2 leaves me with my positive 1x, and on the other side I have 25 halves, and you can just leave it just like that. 12 and a half, that's okay. And just make sure your fraction's as simplified as you can. All right, so let's go ahead and try a few more examples. In these problems, we have the additional complication of parentheses. And really, to be honest, the best thing to do if you see parentheses in an equation is just go ahead and use the distributive property to get rid of the parentheses. Once the parentheses are out of the way, then it's fair game to move things around, combine things, and do whatever you need to do. So here in problem 15, for example, I'm going to distribute that 3 through. So that gives me 3 times x, which is 3x. 3 times minus 2 gives me a minus 6. And that's all that the 3 was touching. That's all that was in the parentheses. This over here is still plus 5x. And then on the other side of the equation, 12 minus 3x, so nothing else there. Now, this time I have 3 x's. There's one here, there's one here, there's one here. I have to get them all together because I need x by itself on one side of the equation and a number on the other side of the equation for this to be done. So let's see how we can get there. First of all, notice that on the left side, I have 2 like terms here, and I can put those together just the way they say because they're on the same side. 3x plus 5x gives me 8x. There was still that minus 6 here. And then on the other side of the equals sign, I have 12 minus 3x. So far, so good. The next thing I need to do is get the 8x and the 3x together. But right now, those are on different sides of the equation. So I have to do a little bit of work to get there. Right now, it's a minus 3x on this side, so I'm going to add 3x to move it over to the other side. You could also minus 8x and then move everything over to the right side as well. I just like to try to pick things that become positive. On this side, I have 8x plus 3x, which is 11x, minus 6. On the other side, I had 12, and then the minus 3x plus 3x went away. That gives me just plus 0x on that side, so that's gone. So now, by rewriting things in this way, what I've been able to do is get a new equation. I have just a single x now, and so I just need to finish getting the x by itself to finish this work. Right now, it's being multiplied by 11 and subtracted 6. So we get rid of the plus or minus first. To get rid of a minus 6, I'm going to plus 6 on each side. That's going to give me 11x equals 18. And then to finish, 11 is being multiplied by x, so I'm going to divide by 11 on both sides. In this case, that's going to give me x equals 18/11. And again, simplify the fraction if you can. Leaving it as an improper fraction is fine. All right, last example for this section here. Again, we've got the parentheses. Distribute to get rid of those parentheses. 6 times 2 is 12. Minus 6 times x is 6x. Plus 4 equals negative 3x plus 5. So again, the 6 is only just being multiplied by those first parts there. Now, I do want to get these x's on the same side. I also right now have some like terms here. You can put those together now or later. I'm going to just go ahead and put them together now. I like to make the equation as small as I can as quickly as possible. In this particular case, because the 12 and the plus 4 are on the same side of the equation, we just do exactly what it says. 12 plus 4 is 16. So I have this new equation version now. 16 minus 6x equals negative 3x plus 5. I have 2 x's. They're on different sides of the equation. So one needs to turn traitor and go over to the other side. So we add or subtract to move it over this time. There's a minus 6x here. I'm going to plus 6x here. You could also add 3x to both sides to move it the other direction. Right now, we'll go ahead and do this. On this side, I have 16. Minus 6x plus 6x moved it away, so that's 0 and gone. On this side, I have negative 3x plus 6x. Add our coefficients, and we end up with a positive 3x from that, and bring down the plus 5. Almost finished with this one. I've gotten it down to where I've got just a single x now, but it's being multiplied by 3 and added 5. Get rid of the plus or minus first, so we're going to minus 5 from each side. 16 minus 5 is 11, equals 3x, and the plus 5 minus 5 is gone. And then to finish getting the x by itself, we need to undo that times by 3, so we're going to divide both sides by 3. 3 divided by 3 gives me the 1x that I need. On the other side, 11 thirds, 3 doesn't go in evenly, so we'll just leave that as a fraction, and that will be my final solution.